today, after quite a bit of ado, this is 072, Math 130, page 1. Lots of blah, blah, blah. Leach doesn't shut up, not really anything new. Today, we want to introduce the idea of solving oblique triangles. This is just an extension of that game we started with. We're going to trigonometry, round 2, and we're starting off with the triangles again. Oblique triangles just means non-right triangles. So oblique just means not right triangles. And we got to talk about this, the tools that we have for solving oblique triangles. So what we'll have is there's not necessarily going to be an obtuse angle. Not necessarily going to be an obtuse angle, but makes it more dramatic. We're going to do the same setup where I call an angle alpha and the side opposite that angle A. Angle beta will be opposite side B. And we don't have a right angle, so we don't have a hypotenuse. So we're going to have to name this third angle gamma. And opposite that will be C, not the hypotenuse. Without a right angle, there is no hypotenuse. No right angle, no hypotenuse. Let's talk about the tools that we have available for solving this triangle. Our toolkit one of the things that we still have is that the sum of the angles in a triangle is 180 degrees. Our toolkit does contain this. Sum of the angles is 180 degrees, but that's true for any triangle. That's the only holdover that we get. The Pythagorean theorem, we don't get. Because the Pythagorean theorem has a hypotenuse and we don't have a hypotenuse. So we can't say sine of theta is opposite over hypotenuse because there is no hypotenuse. So the only holdover tool, the only legacy tool, is that the sum of the angles in any triangle is 180 degrees. We don't get the Pythagorean theorem, but we get the generalization of the Pythagorean theorem. There's a version of the Pythagorean theorem for non-right triangles. There's no Pythagorean theorem because there's no hypotenuse. But we get something even better. We get the law of cosine. So we don't get to use the Pythagorean theorem because we don't have a hypotenuse, because we don't have a right angle. But we can use the law of cosine. Book starts off with the law of sines. I don't know why. I think it's because it's easier to manipulate. This one's easier to make sense of. There are 3 lines. Let's write down the first one, look for patterns. Law of cosine says the following: c squared is equal to a squared plus b squared. Now at this point you're thinking, dude, didn't you just say we couldn't use Pythagorean theorem? And I'm like, oh, hold on, we ain't done yet. C squared is equal to a squared plus b squared. There's another factor, minus 2ab cosine gamma. This is the first line you should learn for the law of cosines. C squared is a squared plus b squared minus 2ab cosine gamma. It's the Pythagorean theorem with that extra term, minus 2ab cosine gamma. If gamma is 90 degrees, then C is the hypotenuse, and the cosine of 90 degrees is 0. So if gamma is 90 degrees, then this is the Pythagorean theorem. So this is the generalized Pythagorean theorem. So if gamma is 90 degrees, then this law of cosines reduces to the Pythagorean theorem. So in that way, we think of it as a general Pythagorean theorem. Note that in this one, I've got only one angle represented, gamma. So there are 2 other versions that have a beta and an alpha. And it's not hard to rearrange. So it's not 3 things that we have to learn. It's one thing, and then we have to learn how to permute it. So instead of c squared and gamma on the outsides, another version of the law of cosine says b squared is a squared plus, anyone want to guess what's next over here? C squared minus, what goes here? Not 2ab, b's over here. 2ac times a cosine of what's opposite b? Beta. And there's a third one. This one involves the angle beta. We still haven't seen angle alpha show up. So if I lead with a squared, what's my first 2 terms going to be? B squared plus c squared. What's this subtracted term going to be? It's not 3 things to note, to recognize. It's just one thing. And it's based on something that you're already familiar with. You start by writing the Pythagorean theorem, then you just write minus 2ab cosine gamma. Or you permute the Pythagorean theorem. B squared is a squared plus c squared minus 2ac cosine beta. A squared is b squared plus c squared minus 2bc cosine alpha. So here's one of the tools that we have in our toolbox. The law of cosine. Generalized Pythagorean theorem. Any questions? I have a question. Why is this all crammed up in the bottom of the page when this is also spread out? What the hell? My priorities are all fucked up right now. Talking about nothing, lots of space. Talking about next important thing, I just cram it into the bottom of the page. So one of the tools that we have is the sum of the angles in any triangle of 180 degrees. The second tool that we have is the law of cosines. Anyone want to guess what I'm going to call the third tool that we're going to have is? The law of sines. You don't have to know what it's called. I'm going to call there's a law of cosines, then there's another one. Is it the law of sines? No, it's the law of tangents. Haha. No, I'm just kidding. It's the law of sines. The other one is the law of sines. There's how we're going to state the law of sines, and then how we're going to use the law of sines. The law of sines says the following. The ratio of the sine of an angle to the side opposite that angle is constant in any triangle. That's how to state the law of sines in words. The ratio of the sine of an angle to the side opposite that angle is constant in any triangle. The ratio means make a fraction of the sine of an angle to the side opposite that angle is constant in any triangle. So there are the three equations in the law of sines. Sine A or sine alpha over A equals sine beta over B. Sine alpha over A equals sine gamma over C. Sine beta over B equals sine gamma over C. So here's what we want to notice about these laws. First of all, this equation that we wrote here for the law of sines, that is a summary of three separate equations. You don't have to write these down, but there are three separate equations. There's sine alpha over A equals sine beta over B, sine beta over B equals sine gamma over C, and also sine alpha over A is equal to sine gamma over C. I spelled C wrong. this way, everything has to get written twice. And since it's always the same value, this fraction is always the same value, you just make one big equation out of it. Here's what we want to notice about the three separate equations in the law of sines and the three different versions of the law of cosines. They each involve four things, of which you have to have three. So each equation from the law of cosines and the law of sines requires three givens to allow you to find the fourth thing. Three known and one unknown. This tells you what kind of given information. This tells you what law to use based on the information that you have. So if we just take this one right above, sine alpha over A is sine gamma over C. If I have alpha and gamma and C, I have 3 out of 4. I could use that to solve for A. If I have alpha, gamma, and B, I can't use the law of sines yet. I mean, if I have alpha and gamma, I could find beta, then I'll have that opposing information. The law of sines requires a full set of opposed information, an angle and the side opposite that angle. So we can make one of these fractions. The law of cosines, each entry in the law of cosines also involves four things. This first line has C, A, B, and gamma, four things. So if you have A and B and C, you can use that information to find gamma. If you have A and B and gamma, then you can use that information to find C. So the law of cosines and law of sines, when we first start solving an oblique triangle, remember we have 3 pieces of given information, and then we have to find 3 additional pieces of information. We start off with those 3 pieces of information. We have to decide which law we're going to use. You don't have to think about it too much. You just have to answer the question, which law can I use? If I have side A, side B, and side C, I can't use the law of sines because I need angles to make the law of sines go. Any questions? You can technically, if you have A and C and alpha, you could use this. You could solve for B in this last one, but we don't want to. We want to do something else. So that's your first task. I want you to take a look at the givens in law of sines and law of cosines. I want to make sure that you can write down the law of sines and law of cosines based on our standard deployment of ABC, alpha, beta, and gamma. And I want you to consider what sets of given information lead to each individual law. When do we use the law of cosines? When do we use the law of sines? Based on our 3 givens, So your job is to say, if the given information is these three things, then we'll use the law of cosines. If the given information is these three things, then we'll use the law of sines. So I want you to take the givens and figure out which law should be used. Any questions? Just to clarify, it's not forever. This is to find our fourth thing. Once we find the fourth thing, then we have options. So it's really, how do we make that first step based on given information? Any questions? Let's take a quick break for 47 hours. That's going to do it for today. I'll see you all on Thursday. We have a couple of days. And thanks for playing.